So our topic for today is approximate analysis of statically indeterminate frames by Portal method. So what is Portal method? The Portal method is based on the assumption that for each story of the frame, the interior columns will take twice as much shear force as the exterior columns. The rationale for this assumption is illustrated in the following figures. So stiffer interior columns assume to take twice the shear of external columns. External columns are those columns na nandito banda sa mga gilid. And those columns inside are the interior columns. So ang ibig sabihin sa portal method natin, it is assumed that lahat ng columns na nasa loob, kung merong column pa dito sa gitna, that is an interior columns. Pag meron pa dito, that's part of interior columns. So most likely, exterior columns, mostly ng exterior columns, dalawa lang yan each floor. So, yan. So exterior columns are those columns na nasa dulo. So assume interior columns, take twice the shear force of exterior columns, and use horizontal equilibrium to solve for F sub 1. So sa portal method, tatandaan nyo lang na all exterior columns have the same magnitude. Kaya yan F1 and F1. And sa lahat naman ng interior column, it's just the twice of the force of the exterior columns. That's why it is 2 times F sub 1. So magkapareho lang yan. Magkapareho lang ito at ito. And lahat ng nasa loob ay ito twice mo lang kung ano yung nasa labas. And yan. So ganyan lang. So this is a simplified structure, top story only. So same for the shear ng second story columns. Ganun lang. Always cut at the inflection points. We will discuss that later. So let's take this example. So draw the shear and moment diagrams of the frame below using portal method. So ito yung ating frame. So there are areas included. So may area tayo ng column na to, which is 10,000 square millimeters. The exterior columns and the other exterior columns, a column. So this is the first exterior column with an area of 10,000 square millimeters. The second exterior column with an area of 15,000 square millimeters, and our interior column with an area of 20,000 square millimeters. So, yung area ng baba is just same as area ng taas. So, let's start. So, first thing to do, step number 1, locate all the inflection points. So you have to redraw the structure and locate all the inflection points in the given structure. So ito yung frame natin. So you locate all. So take note muna. Before proceeding to the drawing, kailangan nyo munang tatandaan that inflection points are located at first, midspan of the beams. Beams, these are the structural elements of the structure, horizontal. These are the horizontal elements. So yan yung, ito, and ito. So yan yung mga horizontal elements, or also called as beams. So nasa gitna nila at midspan. Pag sinabing midspan, nasa gitna ng length, at the mid-length. So andyan yung mga inflection points. And also, Yan. Kung midspan, ibig sabihin kalahati. So, 2.5 of the distance at 2.5, half of the distance ng entire, doon malolocate yung inflection points ng beam. And at the mid-heights of columns. So, ang columns naman, these are the structural, vertical structural elements of the structure. Ayan. Yan yung mga poste, kung tawagin natin. So, dyan makalolocate yung inflection points ng columns. So, kalahati din. So, yung height ng columns natin is 4 meters. So, kalahati-kalahati, dyan malolocate yung inflection points. So, take note. So, remember this always, ha? So, no internal moments at all inflection points. Pag sa inflection points, pag dyan kayo nag-focus, there is no moment, internal moment present. So, meaning walang twisting dyan. Purely X and Y lang. So, only forces X and forces Y ang mag-a-act pag pinutol nyo sa inflection point. So, take note of that. So, always remember that interior columns take twice the shear of internal columns. So, tatandaan nyo yan lagi. So, step 2. So, after nyo malocate lahat ng inflection points ng structure nyo, you are now going to calculate the horizontal shears at the inflection points of the columns, starting from the topmost story going down. Or pwedeng magsisimula kayo sa ground floor going up. It's up to you. So in this case, I started at the topmost. So kinat ko sa inflection points, ayan. So of course, inflection points are located at the mid-heights. So kalahati lang to. So if your story height is 4 meters, so kalahati niya is 2. So we have forces acting dito sa inflection point. So this is denoted as 0.6, 0.7, and 0.8. Kaya dinenote ko siya as force sub x6 kasi x direction. F sub x7 kasi x direction din siya at 0.7, and F sub x8. Pero alam natin na this is an exterior column and this is also an exterior column. So Fx6 is simply equal to Fx8. So kailangan natin muna silang i-convert into one variable only. So Fx is simply equal to Fx6 kasi pareho silang exterior columns. And yung interior column natin, kung i-convert natin in terms of F sub 6, Fx6, so this is simply twice F sub 6 or x6. So yun lang. So now you can proceed to calculating by using the equilibrium equations. So summation forces X is equal to 0. All forces to the right are positive. So ayan. So we have 10 to the right, 100 to the right, so that's positive, minus this Fx6, minus kasi to the left, and minus again, kasi yung F6, yung Fx7 natin is to the left, so negative. At yung Fx6 natin, another Fx6 is to the left, so all in all, equivalent to 0. So we have this simplified equation. So Fx6 is simply equal to 25 kilonewtons. So therefore, Fx6 is equal to 25 kilonewtons. Fx7 is equal to 2 times 25 is equal to 50. And lastly, Fx8 is simply equal to Fx6, which is 25 kilonewtons. So tapos na tayo sa top floor. So let's proceed going down. So this is your structure. So ito na yung consideration natin. Ayan. So kasali na yung dalawang lateral forces acting at joints, yung si 100 kilonewtons and 50 kilonewtons. So pareho lang. Since this is 0.1, kaya pinangalanan ko siya as F sub x sub 1 kasi x direction and then 0.1. This one is forces at point 2 along x, so F sub x sub 2, x2, and F sub x3 kasi horizontal ng point 3. This is point 3. This is point 1, point 2, point 3. And same sa ginawa natin previously. Ayan. So this is F sub x1 kasi pareho silang exterior columns. And syempre si F sub x2 is simply twice as much as fx1. So ganyan lang. So iisang variable na lang sila, x1, x1, x1. So let's sum up. Forces along x is equal to 0. All to the right, positive. So yan. So 100, we have 150 to the right. So positive silang dalawa. And we have isang fx1, dalawang fx1, and isa ulit fx1. All in all equal to 0. So simplifying further. So fx1 is equal to 37.5 kilonewton. So therefore, fx1 is 37.5, fx2 is twice fx1, 75 kilonewtons, and fx3 is 37.5 kilonewtons. Ayan. So calculating the horizontal shear or the base shear, so pareho lang sa value ng ground floor. Actually, pag kinompute nyo yung ground floor, para nyo na rin kinompute yung base shear or the shear at support, the horizontal shear only. Yan. So, what to do next? After step 2, we are now going to compute the internal forces. So you have to indicate all the internal forces in the structure by cutting at the inflection points. So yun ang magiging next step natin after calculating all the horizontal forces at inflection points ng mga columns. We will now proceed to analyzing segment by segment by cutting doon sa may inflection points. Ayan. So you have to indicate all the internal forces. Itong F6, ito, meron na tayo niyan. Itong Fx7, meron na tayo niyan sa previous solution natin. And this Fx8, meron na rin tayo niyan. Meron na rin tayong Fx1, Fx2, Fx3, and yung Vxa, Vxb, and Vxc sa previous solution natin. So what we are going to calculate now are those unknowns na hindi pa natin nahahanap. So yun yung pinakaunang step kasi yun yung pinakamadali. From the assumption of portal method, kailangan muna nating hanapin itong mga lateral or horizontal forces acting at the inflection points of the columns. So yan yung pinaka-first step. Columns, inflection points. Just sum up the forces. Horizontal forces, and then kuha mo na. So after that, kailangan na section by section. So this is one section. Ito, you have to analyze that. This is another section. This is another section. Another. Ito. And ito, and so on, and so forth. So moving forward, yan na pala. Andiyan na yung mga values. So meron na tayong mga values ng mga yan. Yun. So afterwards, para mas klaro, so I indicated all the inflection points. So we have 3 story of analysis. Yan. Story na ano ha, S-T-O-R-E-Y, story. So we have 3 major segments. So, first thing to do, ito muna. So, pag kinonsider natin yung topmost, makaka-create tayo ng tatlong sub-segment. So, this is by joints. So, at joint G, joint H, and joint I. So, we're going to analyze the topmost floor in 3 parts kasi may tatlong joints. So, the analysis is joint by cutting at the inflection points. Yan yung magiging mga boundary natin so that yung mga forces dyan are yung iba are unknown, yung iba known na, but some are not yet known. So kailangan nyo munang i-compute. So let's proceed. So step 4, the analysis by section. So you have to analyze each section of the structure to find all other internal forces by isolating the structure at the inflection points, starting from the topmost story, going down. So start at joint G. Ito yung joint G natin kanina. But sa previous calculations natin, we already got Fx6. So meron na tayo niyan, the 25 kilonewtons. Known na yan. So madali na lang kunin yung Fx9. Kasi just sum up the forces along X and then kuha mo na. So tatandaan lang lagi na pag pinutol nyo sa inflection points, moments are 0. Walang moments dyan. Only forces X and forces Y. So summation forces X equals 0. So to the right, si 100, so positive siya. Si 25 to the left. Ayan, to the left siya. And Fx9 is to the left, so negative. So Fx9 is simply equal to 75 kilonewtons. So positive ang answer nyo, meaning yung assumption nyo na to the left, itong Fx9 is correct. Yan, correct yung answer nyo. Of course, pinutol nyo dito, kung yung sa section na to, ang Fx9 is to the left, yung sa kabilang section, ang Fx9 to the right. Partner kasi yan sila. So now, we're going to sum up moments about 0.9 dito, so that we can calculate the value for Fy6. So Fy6 times the moment arm of 2.5, ito, perpendicular distance, plus 25 times perpendicular distance of 2 meters, all equal to 0. So Fy6 is equal to negative 20 kilonewtons. And lastly, let's sum up forces along vertical axis. All going up are positive. So Fy6, ito, minus going down, Fy9 is equal to 0. So Fy9 is equal to negative 20 kilonewtons. So take note that the negative signs are in the answers only shows that the initial assumptions for the direction are incorrect. For ease of calculations, you can just carry the signs all throughout the calculations and just reciprocate it after. So kung may mga negative signs kayong na-encounter sa mga solutions nyo, hayaan nyo lang, i-carry nyo lang sila sa mga iba nyong solutions, yung negative signs, huwag nyo munang babalik na rin para hindi kayo magkaroon ng problema later on. So, pagka tapos na yung solution nyo, that's the time, i-reciprocate na natin yung mga negative signs to their proper or corrected assumptions. So, next. So, just a quick tip. In choosing the next section to analyze, it is your decision what to choose next, provided that the section that you are going to select will not give you trouble in determining unknown forces. So be wise in choosing to eliminate improper calculations and will not waste your time. So kahit ano naman pwede niyong i-analyze, kung ano yung gusto nyong masunod, kung ano yung gusto nyong sumunod na segment, provided na yung unknowns doon can be determined by just by using the three equilibrium equations. So, yun lang yung tip ng problem na to. So, like for this one. So, meron na tayong point G. So, it is your decision what to choose next. Either this portion, itong yellow, or itong blue na to at joint I. So, joint H or joint I. So, it's up to you kung ano yung gagawin yung ika-calculate nyo sa susunod. So, in this case, let's analyze joint I. So, yan yung joint I. But we already have 25 kilonewtons for FX8, same as with FX6. So, madali lang. So, just sum of forces along X equal to 0. So, Fx10 is equal to 25 kilonewtons. So, wala na siyang ibang kontra. So, summation moments about point 10. So, let's take moments about this point equal to 0. All clockwise rotation will be positive. So, 25. Itong 25. So, iikot siya ng clockwise with a perpendicular distance of 2 meters. So, 25 times 2 minus Fy8, it will rotate counterclockwise. Kaya negative siya. All equal to 0. So, Fy8 is simply equal to 20 kilonewtons. And lastly, summation forces along vertical axis is equal to 0. All going up are positive. So, Fy10, ito, pataas siya, kaya positive, plus Fy8, pataas din, equals 0. So, all in all, Fy10 is equal to negative 20 kilonewtons. So, madali lang. So, meron ka ng joint I. Anyway, you can also proceed after point G, pwede kayo mag-point H. Pwede namang mahanap agad yung mga nodes. So, meron ka ng point G at point or joint G and joint I. So, last is joint H. So, ayan yung joint H. So, lalabas yung mga internal forces at joint at point 9, point 7, and point 10. Yan yung mga inflection points or point of zero moments. Ayan. So, these 75 kilonewtons came from our solution dito sa joint G. Itong 25 kilonewtons and negative 20 galing naman sa joint I. So, and of course, huwag natin kakalimutan si Fx7. May value na tayo kanina. So actually, there is an error, pero the answer is still correct kasi na-compute na natin to, yung Fx7 kanina, we have already computed this one doon pa lang sa first discussion natin with regards to lateral forces at inflection points. So it came out dito sa solution na to na still 50 pa rin. Actually, meron na yan. Kahit hindi na to gawin, meron na tayong answer kanina. But it came out pareho lang. So nothing's wrong with that. So summation forces Y is equal to 0. So positive going up. So we have 20. Ito yung sinasabi ko kanina. Pataas siya, so positive. But you just carry the sign of that value. So negative 20 pa rin siya, but positive kasi pataas yung arrow. Plus Fy7 minus, that because pababa siya, parenthesis, negative 20. So you just carry the sign regardless of the direction. Yung sa direction, magmamatter naman yung assumption nyo. So all in all equal to 0. So Fy7 is equal to 0 kilonewtons. So tapos na tayo dito. So meaning to say, we're already done analyzing the topmost part. So we are now going to proceed to this portion. So i-analyze din natin siya in 3 parts. Itong joint na to, itong another segment, and the third segment. So we have joint D, joint E, and joint F. So let's proceed. So let's start at joint D. So this is our joint D. So yung mga value nito ng f6y and f6x, galing ito sa solution natin sa doon sa topmost part. And ito namang fx1, meron na tayo from the lateral forces using the assumption of the exterior and interior columns. Na exterior columns, interior columns carry twice as much as exterior columns. So meron na tayong value niyan. So ang wala na lang are fy1, fy4, and fx4. So let's solve. So yun na. Lumabas na yung mga values. So let's sum up. Forces along x-axis equal to 0. So to the left, negative. To the right, positive. So we have 50. Sorry. So we have 50 plus 25. Yung 50 na to, itong lateral force acting straight at joint D. So 50 plus 25 minus 37.5 kasi to the left, and minus fx4, all in all equal to 0. So simplifying further, fx4 is equal to positive 37.5 kilonewtons. So afterwards, let's sum up moments about a point. So in this case, let's sum up moments about point 1. So andito yung point 1. So take note, walang moment dyan, but kaya dyan tayo mag-moment. So 50, what is that 50? Ito, 50 times lever arm niya. So iikot siya ng clockwise, so that's why it's positive. So 50 times 2 meters plus 25. That 25 dito galing. 25 times 2, etong 2 plus 2. So 25 times 4 minus fx4, iikot siya ng counterclockwise, that's why it's negative. So fx4 times 2, yung lever arm niya, ito, perpendicular distance, plus fy4, iikot siya ng positive, fy4 times distance perpendicular is 2.5. All in all equal to 0. Simplifying further, fy4 is equal to negative 50 kilonewtons. And lastly, sum of forces along vertical axis equal to 0. So fy1 minus 20. Ito, pababa siya, pero negative. So minus na dahil pababa, and then carry the sign of its value from the previous solutions. Minus fy4, ito, equal to 0. So fy1 is negative 70 kilonewtons. Tapos na tayo sa joint D. So tapos na. Proceed tayo kay joint F. So pwede pa rin kayo mag-next. Pwede pa rin kayong mag-next sa joint E. Pwede nyo i-analyze na agad kasi meron na kayo nitong joint na to. You already have the values of Y and X component ng force dyan, ng internal force dyan. Meron na from this joint kanina. Meron na rin kayo dito, galing kay joint D. Meron na rin kayo ditong X. So, pwede nyo na ma-compute. You have equation 3 unknowns, so kaya nang ma-compute. Pero in this case, I'll be solving first muna si joint F. So joint F, that's why it's your discretion kung saan kayo susunod na magsusolve after one solution. So ito si joint F. So may mga values na yung mga yan. So practice solving, indicating all the details in your drawing. Yun ang pinaka-importante. Without proper drawing, without clear and understandable drawing, mahirap nyo ma-solve yung problem. Lalo-lalo na pag mahina kayo sa imagination, you cannot imagine the distance. Like, kunyari, ang distance is a decimal, not a whole number. Kunyari, the distance is 2.713 meters. So, and then i-divide mo sa 2. So, you have to label everything, di ba? So, you practice solving by indicating all the details in your drawing. So, walang makakaligtaan kahit isa, kahit maliit na moment, huwag niyong kakalimutan. Kahit zero yung value, you include the zero value sa drawing. So that is very important and that is very crucial. So let's sum up. Forces along X. In choosing kung ano yung mauuna, kung summation forces X, Y, or moment, nakadepende din sa inyo. It depends on your assessment sa figure. That's why you have to draw properly the figure. Depende sa magiging assessment nyo sa drawing nyo kung ano yung pwedeng i-apply first and foremost. Kung tingin nyo ba kailangan mo nang mag-moment, so you take moments. Kung kailangan ba muna mag-FY, okay, you take the moments about, you take the forces along vertical. Kung kailangan mauna si FX, depende sa inyo kung ano yung nakikita nyong dapat na paraan, ano yung dapat mauna, susunod, at yung magiging last, nakadepende sa discretion nyo, sa assessment nyo, sa drawing nyo. So you are not required to follow what I am doing right now kasi this is my style of solving. So kayo baka may sarili kayong style, you apply that on your solution. So sum up forces X. So kaya na yan, Fx5 is equal to 12.5 kilonewtons. So next, I sum up moments about 0.5. Where's 0.5 dito? So I took moment about this point. So equal to 0. So 20. Ito, 20 times 2.5 and so on and so forth. And it gave me Fy3 equals 70 kilonewtons. And lastly, I sum up forces along Y and it gave me Fy5 equals negative 50 kilonewtons. So tapos na ako dito. So ang susunod na is joint E, last. So meron na ako nitong joint, meron na ako nito, meron na ako nito. So finally, isa na lang ang kulang ko dito. Kasi meron na tayong lateral force dito from the interior-exterior columns. Yung Y na lang ang wala. So madali na lang. So at joint E. So as you can see, lahat na meron na. Ang wala na lang is the Fy2. So isang solution na lang tayo meron. Summation forces Y na lang. So sum up forces along Y equals 0 and it gave me Fy2 equals 0 kilonewton. So napaka-basic lang. And finally, tapos na ang second floor. And lastly, tapos na to. So finally, ito na. So we're going to analyze the ground floor. Ayan. So we have joint A, joint B, joint C. And whatever forces or whatever values na mako-compute nyo at this inflection points will be the reciprocal or the opposite of the forces dito sa base or dito sa support. So at support A, tulad niyan. So kung dito to the right, automatically dito sa baba to the left. Kung dito going down, dito going up. So they are opposite to each other. So meron na tayong mga values niyan. So just jot it down. So negative 70, negative 70. Positive 37.5 and 37.5. So at support B naman, so yan. Basta tatandaan nyo, pag pinutol nyo yung isang segment ng material, the one part, kung ano yung mga direction doon, yung sa kabilang part, opposite ng kung ano yung direction ng kabilang part. So meron na tayo mga values. And at support C, ayan. Yun. So napaka-convenient. Napakadali lang. So kayang-kaya nyo isolve. So we already done with this, and ito. So this is the complete and corrected shear forces at the inflection point. So kanina, katulad nung kaninang sinabi ko, you just carry all the signs, whatever positive ba yan or negative. Anyway, in the final figure na before kayo gumawa ng shear and moment diagrams, kailangan nyo munang i-indicate all in positive values. So kung nag-assume ka ng pataas and then nag-negative, sa final figure mo dapat pababa na yung force na yun. So this is the corrected and complete. Ayan. Sorry, may harang. Ayan. So ayan yung mga values. So yung mga negative kanina, katulad nito, katulad nung dito sa FY1. Ang assumption dyan nung nauna ay pababa na 70. Pababa. Pero ang tama dapat pataas. Para maging positive to, dapat baliktarin mo to ng pataas. Same as dito. Kung dito pataas, nag-negative siya, ibig sabihin kailangan baliktarin mo, dapat pababa para maging positive. So just like what happened here. Ayun. Kaya naging positive na yung 70, pero binaliktad ko na yung direction ng arrow. Binaliktad ko na rin yung dito yung arrow para maging positive. So lahat ng value dito are all in positive values na. So ni-reciprocate ko na lang yung mga direction na kung pataas siya nung nauna, nag-negative, ibig sabihin gagawin kong pababa. So tapos na yan lahat. And afterwards, you have to analyze the member force. So after calculating all the internal forces in all inflection points, we can now proceed analyzing the structure member by member to determine the member shear moments before we can draw the diagrams. So it means yung mga naunang forces are just initial calculations lang yan. So the real battle will go after having all these values. Kasi kailangan nyo na ma-compute yung mga values ng shear and moments at this point and at this point, at this point, and at this point. So yun yung mga kailangan yung ma-identify. So ito sila, these are initial calculations lang, initial values that you will be using in analyzing member by member. So, this can be accomplished by cutting just after the joint to show the internal forces. Like this one. So magsisimula tayo sa joint G. Ganun pa rin ang analysis natin from top to bottom. So from topmost part to the bottom part of the structure. Ang mangyayari, puputulin natin just right after the joint. So if this is your joint G, puputulin mo right after. The distance is negligible. It's actually equivalent to 0 lang din. So walang moment arm na mag-create. So puputulin mo lang right after the joint. So it will come out like this. So magkakaroon ng moment at G kung saan mo pinutol. That's just exaggerated actually. Pero napakaliit lang ng distance na yan. So this member will be actually analyzed in this manner. Ayan. So kukunin natin, puputulin natin at this point, kukunin natin to, i-analyze natin yan siya. So may lalabas na horizontal. So maneneglect si 100. Kasi pinutol mo na tinanggal mo na. So maiiwan tong si 100 kN dyan sa left part. Kukunin mo lang yung nasa right part na member, itong mahabang ito, itong horizontal na yan. So kukunin mo, may lalabas ngayon na mga forces. Those are the hidden forces of that member. Of course, given na itong si 20 and 75, given na yan sila. So pag nagka-cut kayo, always take the positive. So pag positive shear, pag pinutol mo ng positive shear, the left will be going up and the right will be going down. So anyway, kahit anong assumption nyo, okay lang. Ang importante, dapat positive yung magiging direction niya mamaya sa final answer. So of course, for simplicity of solution, parang kukontrahin nyo lang. Kung may 75 ditong to the left, kontrahin mo dito. Si GX, gawin mong to the right. So that it will be in equilibrium condition. Diba? That is the goal of mechanics. That is the goal na dapat hindi gagalaw yung structure mo. So kung may tumutulak ditong 75 kilonewton to the left, itulak mo din ng GX. So whatever forces na makikita mong value ng GX, that will be the counter force of 75 kilonewtons for this member not to be not for this member not to be able to move. So katulad lang din dito, if may pataas kang load, may upward forces kang 20, so what you're going to do so that the member will not move, applyan mo ng opposite direction dito sa kabila so that it will be in equilibrium condition. But take note, nung pinutol mo, hindi yan inflection point. Pag hindi inflection point, may moment na lalabas. So wag kakalimutan yung moment na mg. So kinuha natin yung right part, so kunin mo din yung right assumption mo. So ito yung sa right, it's clockwise, kasi yung sa left, it's counterclockwise. So kukunin mo yan siya and start the analysis. So summation forces X equal to 0. So Gx is simply 75 kilonewtons. And summation moments about 0.5. So magmo-moment ka sabay 0.5. Actually, that's not 0.5. That's moment about this point or this point. Anyway, kahit saan ka mag-moment, pero wala ka pang gy, so dito ka magmo-moment sa point G. That's point G, by the way. So mg, clockwise minus 20. So counterclockwise times 2.5. So yung 75 is acting, pointing directly dito. So wala na siyang lever arm, so cancel na siya. So mg is simply equal to 50 kilonewton meter. And summation forces y equals 0. So gy is equal to 20 kilonewtons. So I hope you understood the discussion about determining the forces on the inflection points and member forces. So thank you very much and see you to our next video.